Hello students. So today I will discuss the protecting group chemistry. So let's see first the introduction of this protecting group chemistry. So what are these protecting groups? So protecting groups are any group which block or protect the functional group so that it does not react further. So suppose if two functional groups are present in any substrate molecule, and if we want to react any one functional group, then the other functional group has to be protected. So let's see the definition of this protecting group. So how can we define this protecting group? A group which blocks the group which blocks the more reactive functional group temporarily in presence of less reactive functional group so that the more reactive functional group does not react. Is called as protecting group. So let's understand this definition with the help of example. Now, so first we have to protect the functional group to get the desired molecule, to get the desired product, and then after getting the desired product, we should deprotect the that functional group. So this protection is done to get the desired product. So we can write the protection is done to get the desired product. And after getting the desired product, we can deprotect the functional group in presence of some deprotecting agent. So we can write, after getting the expected product, we deprotect, or we can say we remove the protecting group by using suitable deprotecting agent. Okay. So before discussing some more characteristics of this protecting group, so let's see one of the example, and with the help of that example we will understand this definition more clearly. Now first let's take one of the example. Suppose we have this molecule, and in this molecule we have two functional group. One is this keto functional group, and another it contains this ester functional group. Okay, and we want to get the desired product. Suppose the desired reaction, so I am writing the desired reaction. Desired reaction. Okay, so what is the desired reaction? If we react this substrate molecule by lithium aluminum hydride, if we do the reduction of this in presence of lithium aluminum hydride followed by its acidic hydrolysis, then what we should get, what we want to get, we want to reduce only this ester functional group. Okay, so we want to reduce only the ester functional group, and the product that we want to get is this is the product. Okay, so here as you can see, two functional groups are present. Here two functional groups are present. One is this keto group, and another is the ester group. Out of these two functional group, this keto group is more reactive. This is more reactive, and this ester group is less reactive. This is less reactive. Okay, so lithium aluminum hydride, it can reduce both this keto group as well as the ester group. And this lithium aluminum hydride is a very strong reducing agent, so it can reduce both this group. But what we want to reduce this less reactive functional group only. So for this to get this desired product, so that we have only this ester functional group that is reduced. So for this we have to protect this keto group or more reactive function group first. So after protecting it, then we do the reduction so that it gets reduced, and then after getting the expected product, we deprotect this keto group. Okay, so let's see. So what is the, suppose if you we don't protect this keto function group, then what is the actual product? If you are without protection, what is the actual product that we can get? So the actual product of this reaction, actual product without protection, without using protecting group, actual product without using protecting group. So suppose if we have this is keto group and this is your ester group. Okay, so in presence of lithium aluminum hydride and further hydrolysis, then, and suppose if you are taking two equivalent of lithium aluminum hydride. Okay, suppose if you are taking two equivalents of lithium aluminum hydride, of if we are suppose taking excess amount of lithium aluminum hydride. So since this lithium aluminum hydride, it's an expensive reagent, so that's why we should not take the excess one. Suppose if you are taking two equivalent, then in that case both will get reacted. So both will get reacted, and the product that we will get, this will be the product. This will be the product. Okay. Now, so this is when two equivalent of this is used. Now, suppose if we are using one equivalent, suppose one equivalent of lithium aluminum hydride is used, further hydrolysis, then in that case, which functional group will react? The more reactive functional group will only react. Okay, the less reactive functional group that remains unreacted. So out of this two keto and ester, the more reactive functional group is, this is the more reactive functional group because this is more electrophilic center. This is more electrophilic center. This is less electrophilic center. So why this is less electrophilic center? Due to the here this resonance. Due to resonance here, this is the less electrophilic center. So only the more reactive functional group will react in presence of one equivalent of lithium aluminum hydride. So the product that we will get is this one will be the product, and this will remain unreacted in this case. Okay. So what is our desired reaction? So desired, or what is our desired product? So this is our desired product. This is our desired product. So to get this desired product, we should protect this keto group first. Okay. So after getting the expected product, we will deprotect it by using the suitable deprotecting agent. So let's see the desired product with protection by using protecting agent. So now let's do the protection. So we will protect the more reactive functional group. We will protect the more reactive functional group so that less reactive functional group will react to get the desired product. So protection of, we are doing the protection of more reactive functional group. Okay. So for this, to protect this keto group, suppose this is our reactant. So to protect this keto group or carbonyl group, we can use the diol. So here we can use the diol. Okay, so we can use the diol. Okay, so diol, first we can acidify it and then we can use the diol. So after getting this diol, after using, so it will get protected. So this is your product after protection. So you have got the acetal, cyclic acetal. So here this is cyclic acetal is formed. So what is acetal? And this is the acetal. This is your acetal, or OR, we can write OR. This is the acetal, and if we make it like this, if we make it cyclic, then this will be the cyclic acetal. Okay, so now the cyclic acetal is formed, and further, so once this is protected, now we can do the reaction. Suppose we can reduce it by using the lithium aluminum hydride. Now we can add this reducing agent and further hydrolysis, acidic hydrolysis, and we will get the so this will be converted into primary alcohol. So this will be converted into primary alcohol after reduction, and then we can deprotect it. So now this deprotection, after deprotection of this cyclic acetal group, we will get the desired product. So this deprotection can be done by acid hydrolysis. By acid hydrolysis, the deprotection can be done. Okay. Okay. So what we can get, that is the desired product. So this is our desired product. Okay. So let's see the mechanism of this. Let's see the mechanism. So this is the desired product. So if we see the mechanism, so first of all, the protection is done. So this is protonated first to get the strong electrophilic center. Okay. And now, in presence of this diol, so this act as a nucleophile, it will attack this electrophilic center and okay. And this will add over here. Positive charge over. Okay. Now, in next step, what will you get? Okay. So this H2O being a leaving group, it will leave out and we will get here positive center that would be generated, and finally this is deprotected. This is protected now. In this way, a cyclic acetal is, we get a cyclic acetal here. Okay. So this is the protection step. And now we can react it with the lithium aluminum hydride. So now the reduction can be done. So suppose if we have a lithium aluminum hydride, so it will give you the hydride. So this is hydride donor. This is a hydride donor. So this will take over here and okay. So next step, this will go and this will leave out. So and now so this is converted into, in first step, this is converted into aldehyde, and further lithium aluminum hydride reduction. So if again this H minus, suppose this H minus hydride ion, again it will attack over the electrophilic center, okay, and this, and further this hydrolysis. So we will get a alcohol. So we will get alcohol over here. Okay. So this is the expected. This is the product, and now this is this can be deprotected. So now the deprotection can be done. So deprotection. Next step, that will be the deprotection. For deprotection, we can use the, suppose if we use the acid for this deprotection, Okay, dilute acid, or we can use a strong concentrated acid here. So what we can get here, now in next step, so this bond will get broken. Positive center is created over here, and now this H2 being a nucleophile, it will attack at the center, and further what we will get, okay. So let's write here. So in final step, we will get here and now, so we will get a desired product here. Finally, we will get here this desired product. After this, after removal of this H plus, we will get the desired product. So this is the mechanism for this protection and deprotection. In the same way, so this is one of the example. This is one of the example. Let's see. Some characteristics of this protecting group. So I have given the example of the protection of this carbonyl group. In the same way, in next lecture, we will see the protection of this OH group. We will see the protection of diol. We will see the protection of carbonyl group. Some more, so one of the example I have given here, and some more example, some more protecting agent and deprotecting agent for this carbonyl group, that will be discussed in the next lectures. So in the same way, I will this carboxylic group and this amine. So these groups, for these functional group, I will discuss the protection and deprotection in my next lectures. So what are the characteristics for the protecting groups? So what the protecting group, what the features the protecting group should have. So let's see some characteristics of protecting group. So what are some characteristics? Now first one, that the protecting group that should be added always under the mild condition. Means the condition that is, it should not neither be too acidic nor it should be too alkaline condition, or even it should be removed under the mild condition. So we can see, we can write that the protecting group should be added and removed in mild conditions. Mild conditions. So otherwise, it may affect the other function group also. So if we will not use the mild condition, then it may affect the other function groups which are present in a molecule. Next one, the protecting group should be stable also. Protecting group should be stable during reaction. Should be stable during reaction. Otherwise, it may get reacted further. Okay, so it should be stable during the reaction, so that it doesn't react further. So that it doesn't react further. And one of the more another important feature for this protecting group, that after adding the protecting group, chiral center should not be developed in a molecule. Otherwise, if chiral center is developed, then we can get diastereomers, and it means we will get some side products also. We will not get the desired product. Okay, so after adding protecting group, chiral center should not be developed. Chiral center should not be developed. Okay, otherwise diastereomers will be formed, and we will not get the desired product, and we will not get the desired product, or some side product will be formed. So in that case, we may have to isolate the side product also. Okay, and one of the another feature, that the protecting group should be such that the yield of reaction, it should not the yield of reaction, that should be high. So the protecting group should not affect the yield of reaction. So protecting group should not affect the yield of reaction. Okay. So these are some of the characteristics of protecting group. So in my next lecture, I will discuss the protecting group for this alcohol functional group. Okay, thank you.